All right, number 13. This one gives us a statement, compound statement, and it tells us to use variables to rewrite the given statement. So in Hawks, it'll give you two drop-down boxes where you pick what W would be and what statement Z would be. And the only thing really to look out there for is if there are any negations. It's not going to include the word not in the statement it lets you put in the box. You're going to have to use the squiggle when you do the symbols. And we don't have to worry about that one on this one. So if we were calling we will go fishing statement W and we will go swimming statement Z, then the only other thing we really have to think about on this one is what our symbol for or will be. So if we're writing this one in terms of symbols, we would have statement W, and then our symbol for or is an upside down V, Z. Okay, so we would have W or Z. And again, if like what I'm saying in Hawks, if this one said we will not go swimming, then for statement Z, it would let you put we will go swimming, and then you would have to put the squiggle for the Z when you did your symbols. Okay, but if you don't have any negations, this one's pretty straightforward. Okay, number 14. So it gives us a statement, and the statement it gives us is if I go to Venice, then I will visit my friend. And then it asks us is if I visit my friend, then I went to Venice, the converse, inverse, contrapositive, or biconditional for this statement. Okay, so let's take a look at the original statement. The first statement says I go to Venice. And then the second part says I will visit my friend, and it's a compound statement. It's one of these statements put together with if then, or what we call a conditional statement. Okay, so let's look at what happens in the way they change it. It says if I visit my friend, so that's the blue part. Then I went to Venice, so that was the red part. So you can see it stays an if then statement. Okay, most of these do. So the way we figure out if it's converse, inverse, or contrapositive is we have to look at what's done to the parts. So there are three things that can happen. Okay, so the converse it switches. So the part that was first goes last. The part that was last goes first. Okay. The inverse, the way we end up with the inverse is if we negate both sides or both statements. Okay. And then the contrapositive, we do both. So contrapositive, we put those two together and we switch them and negate them. Okay, so what's been done on this one? So we don't have any knots in there. Okay, so we haven't negated anything. Okay, so it's not going to be the inverse because we haven't negated anything. And it's also not going to be the contrapositive because we haven't negated anything. The only thing we've done is we've switched the first statement with the second statement. So we've just switched the order. So on this one, it's going to be the converse. And there was one more option, the biconditional option. And it's really the easiest one. The conditional statement is when it says if then. A biconditional statement is when it says if and only if. So the only way it's going to be biconditional if it says something that means the same thing as if and only if. Okay. Okay, let's look at number 15. Okay. Number 15 says use De Morgan's laws to write an equivalent statement without using parentheses. So if you look, we've got this squiggle out here. So basically, you can kind of think of this like we want to distribute that squiggle sign. Okay, we want to distribute that negation, and that's one of the things that De Morgan's laws do for us. So the version of De Morgan's laws that we want here, there's two versions. Okay, but the version of De Morgan's laws that we want to use here says that if we have a negation out in front of a set of parentheses, then that's the same thing as if we distribute the squiggle. So we would squiggle P, squiggle Q. But what changes, according to De Morgan's laws, is that we flip the symbol in the middle. So if it's an and statement, it changes to an or statement. If it's an or statement, it changes to an and statement. So let's look at this one. We're starting with squiggle, and then inside the parentheses, we've got squiggle P and Q. Okay. So if we distribute that negation, if we add that to the first term, we get squiggle P and squiggle Q. Now that looks weird. You're not used to seeing that. Okay, that's because if we have two negations, oh, I'll mess something up too, right? What else happens? We get squiggle P, but it changes it's not going to be and anymore. It's going to be or, and then squiggle Q. Okay. But again, with those double squiggles, you're not used to seeing that because if we have two squiggles, they cancel each other out, just like two negatives make a positive. So here, instead of writing squiggle P, we just write P. So we have P or not Q, P or squiggle Q. Okay. So that's using De Morgan's laws here, and we've got rid of the parentheses. The other version of De Morgan's laws would start here and then work your way backward. Okay, so this one is they just go different directions. Okay, they say the same thing, they're just different directions. Okay, let's look at number 16. These next few are pretty practical, so hopefully they won't be too confusing to you. Okay, so number 16 says use unit rates to determine the better buy and provide the unit price for your answer. So if we want the unit price, that means we want the price per item. Okay, and anytime you see the word per, okay, so if you see per in there, that tells us we're going to divide something. Okay, so here we want the price per AA battery. Okay, we want to figure out how much it costs just for one AA battery. So the way we would do that, we could figure out the unit price here is we would do $8.99 divided by 8 batteries. So let's see what we get there. 8.99 divided by 8. Okay, we're going to get a decimal. We'll get 1.12375 is what I get. It says round your answer to the nearest hundredth or to the nearest cent. You could say that. So this would round to $1.12 per battery. Okay, that's our unit price there. Okay, so I'll go ahead and write that per battery. Maybe I will. Okay. So now we need to do the same thing for the other scenario here. Okay, so we'll do it in blue. So we would do $22.73 divided by 20 batteries. Okay, so if we punch that in our calculator, 22.73 divided by 20. Again, we're going to get a decimal, but this time it's 1.1365. So if we round that to 2 decimal places, that 6 makes our 3 round up. So we get 1.14 per battery. Okay, so which one's cheaper per battery? Well, the red one is. So our answer would be $1.12 per battery, and the best deal is $8.99 for 8 AA batteries. Okay, number 17. If you've ever worked an hourly job, you've probably done this calculation before. Okay, it says find the unit price. It says you make $399.43 a week. If you work 35 hours, find your hourly rate of pay. We're ignoring taxes and all those deductions here. And we want to round our answer to the nearest cent. So what we're looking for here is we're looking for how much money we make per hour. And we see per, so that means we want to divide. So we're going to do $399.43 divided by, we're working 35 hours. Okay, so let's see what we get there. $399.43 divided by 35. And we're going to have to round here, but that comes out to $11. And then I get 0.412, so that just stays 0.41. Okay, so we're making $11.41 per hour. We are rounding there a little bit, but that's what it told us to do, so we're good there. Okay, one more in this video. Okay, I think maybe not. See you on the next video.